So, can everybody hear me? Great. My name is Julia Suvorova. I am software engineer at Red Hat. And I'm going to talk about uring and how we integrated it in QEMU. So first, we're going to discuss uring API and how cool is it and what's new inside, and then something about QEMU and what's inside. So this is I/O path in virtual machine. We can see that a lot of stuff is going on. So I/O path from user space to kernel, and you need to choose some asynchronous I/O there, and then it connected to QEMU using with I/O block driver, and then we can finally pass through our I/O request to kernel. So what's now existent in QEMU? We can use Linux I/O, but it's not really good because it's not true async. We can use thread pools. We can use NVMe pass-through, which works well, great, but it's not migratable. And SPDK is hard to manage, and so what we can do, we know that we have this path from QEMU user space to hardware, and we can now improve it because we have new I/O ring API instead of existing Linux I/O. What is I/O ring? It is a new, truly asynchronous interface, which was created for block devices, but now it can do everything. It can it's just a good interface to pass messages to the kernel in an asynchronous way. So you can pass network also and do other syscalls. For example, and you can change syscalls. For example, if you have asynchronous open and asynchronous read, you can make that read will go after open, and this always will be asynchronous. So that's cool. And it's part of Linux 5.0 or .1. So it's new. So if we use it in QEMU, we need to make sure that we're on the newest kernel. What's inside a ring? If you remember, in Linux I/O, we have events, and we submitted into a single queue, and now we have two separate queues for submission and completion. And the memory, they're shared between user space and kernel, so you can use it directly. You don't need to enter kernel that. And you can use asynchronous flash, which is not available in Linux I/O. And because of that, we needed to switch back in QEMU to synchronous flash, and this doesn't work good. So to remind you, submission is when it's from user space to hardware, and completion is backwards. So basically, uring is 3 system calls. It's uring setup, when you can manage. You choose different regimes, and you can poll from submission side or completion side. You form your submission queue and form your completion queue, and do enter syscall. What's cool is that you submit requests simultaneously with fetching completion queues. So you don't need 2 syscalls for that. And a great feature is file descriptor register. So you don't need to do fget and fput on each submission and completion. So you just register a set of files and then refer to indexing array. And you can register buffers. This is not a great improvement, but since we in such heavy workloads, such improvement helps. How fast is it? Well, it is quite good. It is better than Linux I/O, but not entirely great. So you can see information with which I test. I use FIO and NVMe SSM. So if uring is so cool, then let's integrate in QEMU. And that's how Stefan Heinotze came up with our tricky idea. And our mentor, Aurshi Mehta, implemented it. And basic functional is actually merged upstream, and it will be in QEMU 5.0. With some problem existed, yeah. How we integrated it? We use the same that Linux I/O actually implemented. We have QEMU event loop. It's based on I/O context. We just add I/O context in the pool and use file descriptor to epoll completion check. And so this is how we can submit requests with enter and check completion on IRQ. We also heavily use liburing, and I can recommend much to use it because it's really helpful. It's easy to use, but now we are tied to liburing versions. Launching is very simple. You just remove your, you put instead of your native or thread, uring, and this is how it works. It works with IO Direct and Cache too, so we can do the same, yes. And you can see that even without extra features, it can do good. You can take a look at base. What we can do next, we can implement F0 registration. So when we have our I/O in QEMU, if we know that it is entered from different file descriptor, we just register it, and that's how we can save some time. Yes, it is improved a little. It doesn't really help much, but one thing of it, it is really helpful when it comes to submission polling. What is submission polling? You need you can run a kernel thread to wait for submissions. You need to wake up it with a special syscall, but if you have a heavy workload, you don't kernel thread just don't sleep. You don't need to wake up it. So it's really helpful. And of course, when we when we pull submissions from kernel threads, we always check FDs, and that's how F0 registration helps. Yes, and now we submit requests without syscall and get completions on IRQ. You see that we don't have any syscalls at all if we have a very heavy workload. What can we do next? We can pull completions from two sides. We can do user space completions. This is a feature in QEMU itself. Instead of using epoll, we can do manual polling sometimes, and it could be good, but it doesn't. It just doesn't work. The feature in uring itself is completion polling. We just submit syscall iron answer and is busy waiting. It is just polling completions, and we're just waiting for it. And you can see that it uses extra CPU, but this is the fastest way. So we have a thread that polls submissions. We are polling completions, and we don't have any extra context change. Yeah, it's not implemented. This is what we need to do. Yes. What we need to do is merge submission polling and file registration. It is implemented, but it needs to be merged. We need to implement file buffer registration and IO poll. It is difficult with IO poll. It takes some time. And we can probably switch to IO ring as default IO if it's supported by the kernel. As we know, it needs a decently recent kernel. Yes, and the final idea that was suggested is switching main pool to IO ring. So you know that we use Linux IO context in QEMU main pool. We can switch it to IO ring context, but this is a lot of work. I'm not sure if we can gain some performance of it, but we can try and take a look. Yeah, I guess that's it. That's a quick presentation. Yeah. Any questions? Yeah.
The way I understand IOUing, it basically is a more Linux-specific way of implementing vHost, right? Different protocol, different things, like less capacity restrictions, but it basically is vHost, right? I mean, you should have it. Like, I was wondering, like, could we literally just expose IOUing to the guest with a couple of restrictions so that it can directly issue calls? Like,
I'm not sure if it's possible.
So
it's really. Yeah, so the question was, it's not really a question. We have vHost, and uring is some sort of vHost, but from the kernel side. Can we take this to the QEMU directly?
To the guest?
To the guest, sorry, to the guest directly. So, well, it's not supported in Linux.
Well, we developed
Yes?
change code.
Sorry. Well, probably we can. Yeah. Well, I don't have an idea if you have something to add.
Yeah. So today it's not possible to do that, but there is someone who's working on it. It will be interesting to see if that helps. Yeah. So the question was about vHost, and it would be possible to expose the rings that Julia described to the guest, and there is someone who's working on it. So we'll see. They'll send patches, and we'll see what happens.
Any more questions? No? Okay, thank you.